So you're studying for the SAT Math Level 2 subject test. You've come to the right place. I'm Dan from WeWillTeachYouMath.com. Guys, when you're using these videos to study, make sure you pause the video at the beginning when the problem first comes on the screen and try it on your own. Most of your practice should be done this way, actively and independently. Then, if after you try the problem on your own, you still find it tricky, that's when you watch the video explanation. In fact, you can use any resources that you have available to you to try to figure it out so that the next time a similar problem comes your way, you'll be ready. Enjoy, and thanks for watching.
43. Observers at locations due north and due south of a rocket launch pad sight a rocket at a height of 10 kilometers. Assuming that the curvature of the Earth is negligible and the rocket's trajectory at that time is perpendicular to the ground, how far apart are the two observers if their angles of elevation to the rocket are 80.5 and 68? A lot of information here. Let's pick out what we need and draw a picture. So we have a rocket launched perfectly vertical, perpendicular to the ground, the curvature of the Earth is negligible, and its height is 10 kilometers. Then we have one observer to the north and one to the south. So let's call this the south guy. He's got an angle of elevation, so I've put him a little less far away, and there's a reason for that. He's got a bigger angle of elevation, so we'll call his angle 80.5 degrees. That's a 0. And then the other guy, he's a little further away, so he's got a smaller angle. He's 68 degrees on his angle of elevation. And they want to know the distance between the two observers. So this is observer south, this is observer north over here, and this is a right angle because the rocket is launched perfectly straight up, perpendicular. So we can use the tangent for each one of these individual triangles to find how far they are from some point that's directly below the rocket's present location, right? The point where it was presumably launched from. So let's call the distance between the south observer and that point x, and the north observer and the same point y, and then if we can find x and y, we can just add them together, and that'll tell us the distance between the two observers. So let's work this out. For the left triangle, we have the tangent of 80.5 degrees equals opposite over adjacent, right, SOHCAHTOA, so that's 10 over x. And then for the other guy, we can say tan of 68 degrees equals still opposite over adjacent, but it's a different triangle now, so opposite the 68 is 10 over y. And then we can solve each of these. So x is going to equal 10 over tan 80.5, and in this case y equals 10 over tan 68. And I've crunched these into my calculator. For x I got 1.67 kilometers, and for y I got 4.04 kilometers. So that's their respective distances from that central point where the rocket was launched. Their distance from one another is the sum of those two numbers, which is 5.71 kilometers. That's choice C.
Hi, thanks for watching. If anything's still confusing or you need a little extra help, drop me an email, leave a comment, or give me a call. I answer every message. And if you want to check out more videos like this, visit WeWillTeachYouMath.com. See you in the next video.